Trigonometric compound angles, part 3. But there's the formula we've already learned in the previous one. Now we're going to use that to find cos of A plus B, sine of A plus B, sine of A minus B. Let's look at cos of A plus B. Now we're only allowed to use A minus B, angle minus angle, so if we're adding, then we have to subtract a negative. Apply the formula. Cos of minus b, cos b, sine of minus b, minus sine b. Remember, that's a nudge and it's fourth quadrant. There we are. And there is our cos of A plus b formula. Sine of A plus b. Now, the only way to get to cos is by using co-ratios, which is 90 minus A plus b. Now, it's no good going back the other way in the formula because we'll have cos of 90 cos of that plus sine of 90 sine of that. We end up back with that, which is just a total waste of time. So we're going to take away the inside brackets and then regroup. There we are. Now we have an angle minus an angle, both with variables. So we're going to write that. Just straight formula. Sine 90, cos 90 minus A, sine 90 minus A, cos A. There we are. And there is our first of our sine compound angles. We've got to go back to the original now, the very first cos of A minus B. So sine of A minus B equals cos of, and we'll have to write 90 minus A minus B. Take away the brackets. Now our problem is this. We could take that there and we could take that, but we have a plus between them and we need a minus. So we're going to have to do the same thing as when we derived that one. We have to write minus minus b. Into the formula, sine A, cos B, fourth quadrant, cos A, minus sine B. So the minus goes to there. There we are. And there's our final formula. Now, these are usually on a formula sheet, but you know, if you rely on your formula sheet, you're going to have trouble in this compound angles because often you are given the actual expansion and you have to go back, and often you may not even realize you have the expansion. Have a look. Cos has the cos, sine, sine pattern. Sine has the sine, cos, sine pattern. Sine, being its name, worries about its sine, so it keeps the same sine. Cos couldn't care about the sine, so therefore it changes. And that's one way to remember. Let's have a look at some examples. We've dropped in, reminded you of the special angles, the graphs as well, and those graphs are quite useful. For example, if you had to know sine of 270 degrees, it takes me longer, maybe it's just my old fingers, but it takes me longer to find sine of 270 on a calculator than just picture the graph going there, oh, -1. Now, sine of 105 without calculator. Now, strictly speaking, you've been well trained, so you'll probably write sine of 180 minus 75, which gives you sine of 75. Which is fun because you can break that down into 45 plus 30, giving you 75. But I've been naughty. I've seen straight away, oh, I can skip the step of reduction formula because I can see two special angles which add to that one. So I'm going to use them straight away. Now that's going to be our sine of A plus B expansion. Therefore, sine cos plus cos sine. Substitute in your special angle values, and there we are. Let's do the next one. Now there, if you don't know your compound angle formulae, you'll probably expand that out, multiply and get a whole mix-up of stuff, which will eventually simplify, but all that exam time, I see the sine cos minus cos sine pattern. Sine cos minus cos sine pattern. Oh, sine of A minus B. Therefore, sine of 2p minus p. Sine of p, finished. The clue will be that this will probably be worth 2 marks in an exam. Next one. Oh, now we have a problem. We have a sine, cos, cos. We don't have a sine, cos, cos. So we have to switch that around. Minus cos, cos plus sine. But we don't have a minus cos cos either. So what we're going to do we're going to write it in brackets. Have a look. Minus cos cos, still minus. Minus minus, because you're plus sine sine. Now we have our straightforward cos expansion there. There we are. Next one. Oh, cos sine sine cos. Well, I'll see that as sine cos cos sine. I don't have a cos sine, but I have a sine cos. Multiplication can be switched around either way. So sine cos cos sine. That's the addition for sine. Let's add the angles. 150. Second quadrant, 180 minus 30. Positive for sine. That gives us our half. Next one. Oh, we have different angles. How are we going to cope with this one? Well, if you are disciplined in trigonometry, you'll know you need to reduce them. 360 minus 58. Positive cos. That stays. 180 minus 58. Positive for sine in the second quadrant. 180 plus 32. It'll be negative, taking the negative to there, because that's third quadrant sine negative. There we are. Now we have the cos cos minus sine sine. There we are, cos of A plus B. Cos of 90, oh, picture the cos, 90, oh, naught. Next one. Now here, you may write that as 45 plus 30, 45 plus 30, do two terms here with 4 different values, 2 terms here with 4 different values. You'll get there in the end, but it'll take ages. It's not worth it. Have a look. I recognize that as a special angle. Special angle ratio. I recognize that as a special angle ratio. This is either sine of 30 or cos of 60. Sine of 60 or cos of 30. So I'm going to write it as such. There we are. Now I've got cos cos, sine sine, minus, which means I now have this addition. Therefore, 135, second quadrant, 180 minus 45, cos negative in the second quadrant, negative cos 45, negative root 2 over 2. Now you might say to me, well, why did you choose cos 60 and not sine of 30? It really doesn't matter. Here we go. Here's using sine of 30. Sine of 30, cos of 30. Same routine. Next one. Similar to that one, where we have a factor now, root 2. But root 2 is not actually a special angles ratio. We've got root 2 over 2, but nothing else. So let's multiply it out. Why don't we make it into root 2 over 2? We'll make these root 2 over 2 as long as we counteract it. There we are, root 2 over 2, root 2 over 2, and we put a 2 outside the bracket. 2 times root 2 over 2, root 2. 2 times root 2 over 2, root 2. There we are. Root 2 over 2, cos 45. So we have cos cos plus sine sine. There's cos cos plus sine sine, cos of A minus B. We could have done that. We could have used sine cos there instead, and use the sine expansion. But we'll just keep with the cos one now. There we are. 2 cos 30, 2 times root 3 over 2, root 3. If you'd put sine there and cos there, you would have ended up with the same answer. Now here are a whole lot of examples for you to do. Pause and try them. The answers are coming later. Here's the next lot. Pause, try them. Let's go with the answers. So this is the first one. Expand. Now we're expanding. So we're just applying these formulas. So it's a case of recognizing A minus theta, first one. There we are. This looks interesting. Oh, there we are. This is recognition. Cos x cos y minus sin x sin y. So we say cos sin sin, that's cos expansion, minus means there's a plus in the middle. Cos sin sin plus sin means there's a minus in the middle. Sin cos minus cos sin means it's the sin expansion minus in the middle. Remember, minus sin cares for its sign. And sin cos sin with a plus means sin with a plus. Cos sin sin with a plus means cos with a minus. And sin cos sin means sin with a plus. Yeah. Next one, case of recognizing sin cos sin with a minus. Oh, that's a sign with addition. Sign with subtraction, sorry, it's my old age. Right, sine of 30, which is a half. Sin cos sin, sign with addition, and there is sine of 45. Sin cos sin with a minus, yes, sine with a minus. Sine of 90, oh yes, there it is, trig graph. We can reduce these, but have a look, they are the same, so we can just go for it straight from there. It's the sine with a plus. Here we are. Sine of 270, 90, 180, 270, there we are. Negative 1. $110, $110, $20, $20. We don't need to reduce that. Cos with a minus. Cos of 90, naught. This next one's a problem. Different angles throughout. So all we're going to do is we're going to leave that, reduce that. 180 minus 35, sine positive. 180 minus 80, sine positive. There we are. Sine cos with a negative means that's the sine expansion with a negative. Sine of negative 45, fourth quadrant, negative. And there is our answer. Here we are. This one we need to reduce as well. So let's do that first. There we are. 8742, 8742. Useful. Sine cos sine, sine with a minus. Reduces to sine 45 root 2 over 2. Right, a bit more calculation here. Here we are. Write a sine or cos function of the compound angle. Root 3 over 2 cos 30 minus half sine 30. That we recognize. Special angle ratio, so we can do that. Let's write cos 30, sine 30, sine 30, which gives you cos of 30 plus 30. This one here. We can do the same thing, special angles. Ah, yes, of course. Let's go back to this one. Notice I used sine as well. Either will work. Cos of 60 is the same as sine of 30. There we are. Using the coses, using the sine. Use either cos or sine there. You'll get the same answer. Right, well, we can use coses, or we can use sine and coses. That gives you cos of 90, which is 0. This gives you sine of 0, which is 0. This one here, well, we could simplify and just say that's minus cos of 10, hey? But that's not what we've been told. We've been told to write as a sine or cos function of a compound angle. So we're going to have to say either sine or cos to give you minus 1, either sine or cos to give you 0. So there, let's do 270. And there's the expansion. We could have used cos 180, sin 180. Okay, determine without calculator. Well, which two special angles add to give 75 degrees? 45 plus 30. Sine expansion. Slot in your special angles. Simplify. B, cos of 75. Well, same process. 45 plus 30, compound angle. That should be a minus. Oh dear. Ah, it's back to a minus. Typing error, typo, sorry. And that gives us our answer. Having tipped out the previous questions, on to the next. Tan of 75. Well, tan is sine over cos. We've just found those. When you divide by a fraction, you multiply by the inverse. There we are. You see it's flipped and you're multiplying it. And there we are. 4's cancel that over that. Sine of 15. Well, you could go through the process. That's 45 minus 30. You could go that way, or you could be observant. Well, think cosine. Sine of 15 is cos of 90 minus 15, which is cos of 75. We've already found that. So let's think. There's our previous screen where we found cos of 75 degrees. We think, well, all right then, cos of 75. So therefore, there's our answer. There we are. Dividing by a fraction, multiply by the inverse, or just flip it. There's our answer to 1 over sine 15. We're getting there. Cos A plus B minus cos A minus B. Now, this prove that this equals that. I can tell you what, that if you look at these things and say, well, I'm trying to see how I get there, don't do that. What you must do is just forget this side and say, well, I'm going to simplify that as far as possible. This guides me that says, well, obviously they're cos, cos, sine, sine, so I must just expand them like that. So I'm going to take left-hand side. Remember, you cannot work with both at the same time. You're trying to prove it, and it's very bad maths. It's incorrect maths to have this equals that going all the way down. Left-hand side, there we are. Expansion, expansion. Take away the brackets. Now we have cos A, cos B, minus cos A, cos B. Cheers. Minus sine A, sine B, minus sine A, sine B. We have two of them. Magic's magic. That is the right-hand side.